Process in which a metal is oxidized by loss of electrons to oxygen and formation of oxides is known as corrosion. It slowly coats the surfaces of metallic objects with oxides or other salts of the metal. The given figure shows the corrosion process. You can see anode action causes pitting of the iron. You can also see cathode action reduces oxygen from air, forming hydroxide ions. You can also see iron hydroxide forms and precipitates. You can also see the hydroxide quickly oxidizes to from rest. The electrochemical cell action driven by the energy of oxidation continues the corrosion process. The reaction taking place at anode is 2Fe gives 2Fe plus 2 plus 4 electrons. The E naught of the reaction Fe plus 2 2Fe is equals to minus 0.44 volt. At cathode, the reaction taking place is O2 plus 4H plus 4 electron gives 2H2O. The E naught for this reaction is 1.23 volt. The overall reaction is given by 2Fe plus O2 plus 4H plus gives 2Fe plus 2 plus 2H2O. The E naught of this reaction is 1.67 volt. Note that the ferrous ions are further oxidized by atmospheric oxygen to ferric ions, which must come out as rust in the form of hydrated ferric oxide, that is Fe2O3.XH2O, and with further production of hydrogen ions. Rusting of iron. Corrosion of iron is called rusting. Iron rusts when it is left out in the open air or is in contact with water. Rust is a mixture of iron oxide, that is Fe2O3, and iron hydroxide, that is FeOH whole thrice. It appears on the surface of iron in the form of a red-brown flaky coating. The reaction taking place is given by 4Fe plus 3O2 plus 3H2O gives Fe2O3 plus 2FeOH whole thrice, which is called as rust. There are two conditions necessary for iron to rust. The first one is presence of air. Iron rusts when it is exposed to damp air. Note that damp air contains oxygen as well as moisture. The second one is presence of water. Iron also rusts when it is in contact with water. Note that water contains a little amount of dissolved gas. Promotion method. The first method is in the presence of dissolved salts like sodium chloride, iron rusts faster. The second method is in the presence of dissolved gases like carbon dioxide, nitrogen dioxide, and sulfur dioxide, iron rusts faster. The third method is when iron is placed in contact with a metal that is less reactive than it, rusting occurs faster. Effects. Rust is soft and porous. It gradually eats away into iron. Further, it can peel easily off the surface of iron, exposing fresh surface for further corrosion. Note that when objects made of iron are placed in contact with damp air for a long time, they rust completely. Prevention of corrosion. Iron can be protected from rusting by preventing its exposure to oxygen or moisture. Iron can be prevented from rusting by covering its surface with paint, grease, enamels, or liquids. Iron can be galvanized in order to prevent it from rusting. Note that coating iron with zinc is also called sacrificial protection. This is so called because zinc is sacrificed to protect iron. Iron can also be protected from rusting by coating its surface with metals like tin, chromium, and nickel. Iron can be prevented from rusting by alloying it with carbon and chromium. Iron alloyed with carbon and chromium is called stainless steel. Stainless steel does not rust